Assalamu alaikum. In this video, I hope to discuss hygrometry in thermal physics. This is one of the section that is confusing for most of the students. So I thought to do a quick um, recap on this part so you all can get a better idea about this section. Um, Hygrometry or this humidity is confusing because you'll find it hard to understand what is happening here. So I have a very simple analogy where you can compare humidity to a normal classroom. So let me introduce my comparison. Say, what is humidity? Humidity is the amount of water vapor that is present in a unit volume. Okay, if you take a unit volume, the amount of water vapor that is present, that is, let's say m, then humidity, absolute humidity is m over v. Now let's see how we can compare this to a classroom. So in our example, the classroom is going to be the volume. Okay, classroom is going to be the volume, and the chairs that is available, is going to be the maximum number of available space, and students who occupy the space are the water molecules. Okay, otherwise the vapor. So in our comparison, students is the vapor. Okay, students is the vapor, and these available space that is the chairs. Okay, and the volume is the classroom. Now let's see how AH and RH relate to each other. AH is the currently available amount. Okay, so here if you check how many spaces do we have? We have 12 spaces. Okay, we have 12 chairs, and that is the maximum amount we can have. If we have 12, this room is saturated. Now that is the maximum amount we can have, but currently how much do we have? We only have 4 of the students. So this classroom is nearly 33.33% occupied. So that is the RH, the maximum amount over the current occupation. Okay, now how can we increase the RH? How can we increase the RH and AH? So let's see what factors affect RH and AH, and we can easily understand the idea using this classroom analogy. So let me take AH versus time and RH versus time. So here first let's see what would happen if we add water vapor. Let's see what would happen if we add water vapor. So if we add water vapor, what is water vapor analogous to? It is analogous to student. Okay, so if a student enters to this classroom and occupies this space, what can you tell about the AH? What is AH? The current occupation. So here, how many of them are there now? 8. So if another student comes in, 9. You understand that when I add water vapor, AH is increasing. Okay, but see, when AH is increasing, let's say now this classroom has 12 students. Can another student enter the classroom and take a seat? No, because it is occupied. That is why this becomes constant. And what do we call it? We call it as saturated. Okay, we call it as saturated. Let's say the time at which it saturates is T naught. Now, let's see how RH is going to change. Let's see how RH is going to change. For that, let me clear this. So, what is RH? RH is the maximum amount current occupation over the maximum amount. So initially when those students are going to occupy the space, what can you tell about the percentage? It's 1/3 of the classroom, right? Now only 1/3 is filled. So the RH is 33.33%. Okay. And let's say another two students enter the classroom. Then what is the occupation now? We have 12 spaces, 6 of them are occupied. That means it's 50%. So you understand that when the number of students increase, the occupation increase, the percentage increase. So RH is going to increase. Okay, RH is going to increase. But look, if we have 12 spaces and 12 students are in the classroom, now what is the percentage of occupation? You have 12 space and 12 of them are occupied. That means the classroom is saturated and the RH is 100% when at time T naught. So this is the graph we get when we add water vapor. Hope it's clear. Then second, let's see how it would vary when I change the temperature. Okay, when I change the temperature, let's see how this graph is going to vary. For that, let me clear this once again. So to understand how temperature is going to affect RH or AH, we need to understand what is temperature going to change here. Does it going to change the number of students or will it change the available space? We should understand what it is going to change. Okay, so here comes the next important thing you have to remember in this analogy. If I increase the temperature, available space is going to increase. Okay, then if I reduce the temperature, available space is going to reduce. Now let's see how RH is going to change when I change or when I decrease the temperature. Okay, let's see how RH is going to change when I decrease the temperature. So how many students do we have here? We have 12 available space. We have 12 available space, but how many students do we have? We only have 4 of them. Okay, we only have 4 of them. So if I reduce the temperature, it will reduce the available space. Okay, it will reduce the available space. So Say I am gradually reducing the temperature. Now I have 12 space. When I reduce the temperature, it becomes 8 space. Now we only have 8 space. But what happened to the number of students? It didn't change because we only have 4 students, but we have 8 seats left. So AH didn't change. Then let me further reduce the temperature. If I further reduce the temperature, now what happens? Now the available space becomes 4 and number of students becomes 4. Now say I further reduce the temperature. If I further reduce the temperature, now comes the problem. I have to remove a student and a space. So space becomes 3, student becomes 3. So you understand that AH will not change until the maximum becomes equal to the current occupation, or otherwise let's look what's happening to RH. Earlier when I remove these chairs before I remove the chair, the RH was how much? 1/3, 33%. Okay, RH was 33%. So RH is 33%. When I remove this set of chairs, RH became 50%. Okay, when I remove this set of chairs, now RH becomes 100%. If I remove now, still it will remain at 100% because 3 available, 3 students, 2 available, 2 students, 1 available, 1 student. So you understand that when RH has become 100%, it will not change. Similarly, what about the AH? AH also, so until RH become 100%, what was happening? RH was gradually increasing, I mean the available space was decreasing, but until the numbers are equal, it will not change. So until RH becomes 100%, it will not change. After that, it will start to reduce. Okay, hope the idea is clear. Then what if I increase the temperature? What if I increase the temperature? If I increase the temperature, say we have 3 students and available spaces are there. If I increase the temperature, then what happens to the available space? It will further increase. So RH reduces, right? RH reduces because only 3 are occupied, but the remaining are empty. So you understand now the percentage is 25%, less than the 33%. Okay, so you understand that when I increase the temperature, with time, RH reduces. Okay, RH reduces. What about AH? What about AH? Did the number of students change because I changed the temperature? No, right? They remain the same. The number of available space changed, but the number of students didn't change. Therefore, AH remains constant. Hope you understand the idea behind these questions. Let's come back to this. Here, when I was reducing the temperature, you see that when RH becomes 100%, AH starts to reduce. Until then, it didn't reduce. And this point is what we call as the dew point. Okay, this is what we call as the dew point. So dew point, you understand that dew point doesn't depend on the temperature, because whenever the RH becomes 100%, dew forms. Okay, because the available space is occupied, and if I reduce the temperature at any temperature, maybe above room temperature, below room temperature, or any temperature, if I reduce the temperature, it will start to condense because the available space is occupied. Hope you got an overall idea. Let's try some questions, then you will see how we can apply this idea to the questions. So one thing to remember, the AH at room temperature, or the initial AH, or say the AH at room temperature, is equal to AH at dew point. Now this is a very important idea you have to remember. If you didn't understand how it happens, let me explain it once again. You already know the idea. Now look, this classroom has 4 students, right? So there are 8 available spaces. So if I reduce the temperature, then these spaces or these chairs are taken away. But did the number of students change? No. Let's further reduce it. Did the number of students change? No. But we have come to the dew point, because if I reduce it further, it will condense. So look, still we have 4. So initially at room temperature we had 4. Now at dew point also we have 4. So this idea is very important when we try questions. Let's see. Adding water. Now we want to increase the RH inside a closed chamber. So adding water vapor to the chamber. Here the available space remains constant and we are adding more students. That means at some point it will get saturated. So RH will increase. By decreasing the temperature inside the chamber, here what would happen? Let's say we have available space of 50 and 30 are occupied. Okay, 30 are occupied and 50 is available. Then what is the percentage? 60%. Okay, 60% is the RH. If I reduce the temperature, available space will reduce and this will become 40. Then the RH becomes 75. If I further reduce, this becomes 30. Then the RH becomes 100%. Therefore, RH increases, right? RH increases, decreasing the volume of the chamber. So how we can think about that? Now, just think about a large classroom. There are many chairs and there is only 4 students. Okay, so in a large classroom, there is only 4 students. If I put them into a small classroom where we only can fit in 4 students, then here RH automatically increases, right? Because the volume is less. But here these 4 students are in a huge volume where there is more space. Then here the RH is less. Therefore we understand that by reducing the volume also we can increase the RH. Therefore all ABC are true. Next, dew cannot appear if temperature is high. Now just recall what I said about dew point. Does dew point depend on temperature? No. Dew point does not depend on the temperature. Okay. Dew point, is it temperature dependent? No. Then when does dew form? If RH is 100%. If RH is 100%, you will see dew. Then dew point temperature. Can it be greater than room temperature? Yes. Can it be less than room temperature? Yes. Can it be equal? Yes, because we only have to look for RH being 100%. So will dew form? Yes, because RH is 100%. Dew will form. Temperature is low. Absolute humidity is equal to corresponding value at dew point. That means it is a dew point, right? AH and dew point. That is what I told earlier. So this is already at dew point. Temperature is high. Absolute humidity is equal to corresponding value at dew point. Once again, it is the same idea. It is at dew point. Temperature doesn't matter, therefore dew will form. Temperature is below dew point, RH is 100%. If RH is 100%, dew will form. Temperature is low, the absolute humidity is less than the maximum possible value at that temperature. That means RH is less than 100%. Therefore, here dew will not appear. Okay, let's look at this question. Large vessel is placed inside a closed room having RH 50%. So if we keep a cup of water open in a closed room, after some time this will evaporate and turn into water vapor. So statement A, absolute humidity inside the room will increase continuously. So let's think about that. Now our room is similar to the classroom. Okay, then already we have 50% of the occupation as they have mentioned. That means 50% of the classroom is filled. Okay, then because we have kept water inside this room, it will start evaporating. That means it's like student entering into the classroom. Okay, so it will occupy these spaces. After some time, this room becomes saturated. So the student who would come next, do they have space? No, right? Then what would happen to the absolute humidity? Initially, it would increase and come to a constant value. But here they say it would increase continuously. Therefore, wrong. RH inside the room stays constant. No, right? Because earlier it was 50. At some point, it will become 100%. Once it becomes 100%, after that, it will be constant. Therefore, this is also wrong because it has to go from 50 to 100. Dew point of the room become equal to the room temperature. Okay, so here you understand that RH is becoming 100% at the room temperature itself, right? If the RH is 100% at the room temperature, that means the dew point temperature is the room temperature itself. Therefore, statement C is correct. Then the answer is only C. Let's come back to this question. Let's try this and count. Here we have a certain volume of air isolated from atmosphere at 30 degrees Celsius. It is first heated up to 80 degrees Celsius. Now let's think quick. We have air at 30 degrees Celsius and we increase the temperature to 80 degrees Celsius. Okay, we increase temperature to 80 degrees Celsius. What will happen to AH? Will AH change? AH, it is equal, because as I mentioned earlier, AH is the current occupation, right? When we increase temperature, what happens? The free available space, that is what it is going to increase. So RH will decrease. Okay, RH will decrease. Next, what do? They cool to 15 degrees Celsius, but the dew point is 25 degrees Celsius. So from 80 degrees Celsius, we cool to 15 degrees Celsius, but the dew forms at 25 degrees Celsius. Okay, let's look at the graph. RH and AH. When I increase the temperature, what should happen to RH? RH has to reduce. So the second answer says that RH is increasing, which is not possible. Then the remaining answers are possible. Okay. So what are we doing initially? Initially, we are increasing the temperature. If we increase the temperature, RH will reduce. RH will reduce. Next, we are reducing the temperature. When we reduce the temperature, what happens to the available space? Reduce. Therefore, RH will increase. All this time, what about AH? AH will remain constant. Until when? When RH becomes 100%. Now this is at 25 degrees Celsius, okay? That is when RH becomes 100%. I further reduce the temperature, RH will remain constant. Why? Just recall that example. Call the classroom example. Let's say we had 40 space and 35 students. So until this available space reduces to 35, no change. After 35, available is 35, students is 35. If I reduce the available to 33, students also will reduce to 33. This is the age, this is the actual amount present. So look, it has to reduce. Why not the other answers? If you look this answer, when RH is becoming 100%, still AH has not started to decrease. Here, before RH becoming 100%, AH reduce. Here also the same. Even before RH becomes 100%, AH is reducing, which is not possible. Then the answer should be first. Let's look at this question. First of all, we are taking in air at 30 degrees Celsius. RH is 80%. Z is 30. Y is maintained at 0 and Z is maintained at 40. Sorry. So they have given the SVP at 0, 30 and 40. Then we want to find what is the RH and AH in X, Y and Z. So in X, RH is 80. They already have mentioned. So what is RH? RH is current AH over the saturated, right? Current level over the saturation into 100%. So that is 80% for X. Then they say at 30 degrees Celsius, the maximum is 30 into 10 to the minus 3. Then simple M is equal 80%. That means 0.8 into capital M. Capital M is how much? The maximum, right? 30. So 0.8 into 30 would give me 24. So 10 to the minus 3. Then what should be the AH? From uh, 30, only 80% is occupied. That means 24. So we can cancel the first answer because it says 30. All the other answers are valid. Now let's go to chamber Y. In chamber Y, we are maintaining the temperature at 0 degrees Celsius. Okay, so what is the maximum amount we can have at 0 degrees Celsius? 4.8. But look what's happening. When we are sending the air from X to Y, in X, how much do we have? We have 24 into 10 to the minus 3. But what is the maximum amount or maximum available space in Y? That is 4.8 into 10 to the minus 3. So whatever additional in 24, whatever additional should condense, because think about that classroom, we only have space for 4.8 people, but 24 are trying to come in. How much space can be provided? Only 4.8. Others have to remain out. That is condensing. Okay, so now what will be the current AH in Y? That is 4.8, and that is the current amount. And what is the maximum amount we can have? That is also 4.8. That means it is 100%. So we can cancel the third answer, which says 0. Others stay valid. Now, how much do we have in air? Only 4.8 when going from Y to Z. Okay, when going from Y to Z, we only have 4.8. What happened to the others? Others condensed. So when reaching Z, we have 4.8, and what is the maximum we can have at that temperature? They say 48. So look, when we are increasing the temperature, AH doesn't change, as I mentioned earlier. So as a percentage, it is 10%. So AH is 4.8 and RH is 10%. Then the answer is second. So that's it about this presentation. Hope you got an idea about how to approach these humidity questions. Thank you.